Okay, so welcome guys. So in this video, I want to talk about the Markovian or Markov's identity. I should add S. Okay. Most of my videos are basically the theoretical results. So I seldom do examples. Okay, so in this video, let's just talk about proof, and maybe in a few videos we can do a lot of examples. Okay, so the settings, the theorem is that the x is a non-negative random variable. Okay, so basically x is non-negative. Basically, so x can only be choose non-negativity. Okay, so a is greater than 0. Then you can check that the probability that x greater or equal to a is less than exponential of x divided by a. Okay. So okay, so that's the results. Okay, so if you are familiar with the like a major theory, let's say if you're working in the major theory, so sigma is the sigma algebra of x, and the mu is a major. And then you can check that if you take basically and then you take this, you can view this as the back measure. So f of x, f is a measurable function defined on x. Okay, so this one is this volume, you can verse volume is less than the total f d mu. Okay, but in this video we will only concentrate on the probability results, so I only prove this, but this is also similar. Okay. Yes, and there's an extension. Let's quickly talk about extension. So extension, one extension is that p like x greater than a, right? If you have any like any random variable, then you can prove it's always this. Okay, for some phi, which is monotonically increasing. Okay, and non-negative. But this we will not prove this. In this video, we only prove this. Okay, so let's see what is a proof. So the first is that we prove the continuous version. So e of x is divided by x f of x dx, right? Because this f is so-called a PDF, and we already assume that x is non-negative. So basically, e of x can only be survive when f of x is positive. So 0 to infinity x f of x dx. Okay, so let's take any a, right? We can take any a. So let's say it's just 0 to a f of x x dx plus a infinity x f of x dx. Right? So this guy is positive, right? So easy way is that we just say that this guy is positive, so we can just change this as a to infinity x f of x dx. Okay, and I can change it as this to a, right? I can change this as greater or equal to a because s larger than a, right? So I can change it to this. Okay, and this is the probability which x greater than a. So probability x greater than a is less or equal to a e of x. Proof. Okay, and although it seems that we proved the continuous version, right? But you can take the discrete measure or the delta measure of f of x. So it's easy to see that once you prove this, you that f of x to be the delta measure. Then it's easy to and directly to show that it works for the general case. Okay, and another proof is using like the major theory. Okay, so I think it's not important for us to prove. Okay, we only need to prove this. Okay, and the next consequence I hope to establish is that the Chebyshev identity, because the Chebyshev identities, Chebyshev inequalities, right, can be directly see from the Markov's identity. Okay, so and it's basically, so let's say, so this is Markov, right? Markov tells us that x greater than a, for the positive is less than this. Okay. And Chebyshev tells us that so let's talk about theorem. So let's say for a random variable, right? Given a random variable which is e of x is well defined, because for some random variable that the expectation values will well defined, right? So let's assume that expectation value is well defined, and the p of x minus e of x. So basically, you ask about the change, right? The how large is deviated from original. So this guy will less than a square variance of x. Okay, so the goal is that we want to prove Markovian identities to Chebyshev's Chebyshev inequalities. Okay, inequalities to inequalities. Okay, so it's obviously that we know variance x is defined to be exponential expectation of x minus expectation of x. Let's say, right? So this guy is also a random variable, right? And then you can take a square and then take the expectation value. Right, this is the very broad definition of variance. So so you see this guy, if you carefully see this guy. This guy is what? This non-negative random variable. Okay, so let's let y to be x minus e of x, and square. Okay, so from this Markov inequality, we get py greater or equal to a is less than 1 over a. E of this, right? So it's var x. Okay, but why is y greater or equal to e, right? Y greater or equal to e means that square is equal to greater or equal to a. So it's the same as this, right? So we get px minus p y square root of y greater or equal to a less than a square. So this is a square var x. Okay. Y. So one might think that y is I should say this is a square. Okay, so y greater or equal to a square, and then take a square root. Okay, you get this. Okay, so yeah, so this is the Chebyshev inequalities proof. Okay, and you can use we will also have the generalization of the Chebyshev inequalities, like the generalization of Markov inequalities. Okay, so I think that's the proof. So we introduced two inequalities in this video. One is Markov inequalities, one is the Chebyshev inequalities. And in the next videos, we will have more and more like the probability inequalities, and I will make a clean connection of them in the future. Okay, be sure to subscribe to my channel. I will see you guys in the next videos. Thanks.